This is the new Marine One, America's most advanced presidential helicopter, but this $217 million aircraft got so over-engineered that it almost never made it to service. It scorched the White House lawn, failed its communications tests, and got called not operationally suitable by the Pentagon. Now, its innovative engineering is the only thing between the president and a very long walk to Air Force One. The helicopter waiting on the South Lawn is a scorched VH-92A Patriot, and it faces a problem no commercial helicopter has ever confronted. The civilian S-92 it was based on was built to carry oil workers to offshore platforms. Tough conditions, demanding flights, but straightforward requirements. Get people there, get them back, don't crash. Sikorsky designed it for reliability and efficiency. Airlines around the world trust it for exactly that. The VH-92A started with those same bones. Then the Marine Corps added requirements that push the airframe to its absolute limits. Armor plating surrounds the cabin where the president sits. Ballistic glass fills the windows, each pane thick enough to stop rifle rounds but heavy enough to affect performance with every square inch. The fuel tanks are self-sealing, designed to close around punctures rather than spray jet fuel into an engine fire. Redundant flight computers, redundant hydraulic systems, redundant everything, because Marine One doesn't get to have single points of failure. Add the classified communications suite, the defensive countermeasures, the electronic warfare systems, and suddenly you're looking at an aircraft that weighs nearly 27,000 pounds fully loaded. The commercial S-92 tops out around 24,000. 3,000 pounds doesn't sound like much until you understand what it means for a helicopter. Fixed-wing aircraft can compensate for extra weight with longer runways and higher speeds. Helicopters can't. They have to lift straight up, hover in place, and land on a patch of grass no bigger than a tennis court. The rotor system that worked fine for the S-92 now has to work harder. The engines that provided comfortable power margins now run closer to their limits. The transmission that transferred force smoothly now absorbs more stress with every flight. Look at the VH-92A sitting on the South Lawn before its trip to Andrews Air Force Base. It looks almost identical to the civilian version. Same fuselage shape, same rotor configuration. The only visible difference is the iconic white top and green bottom color scheme that Marine One has worn since Eisenhower. But underneath that familiar exterior, engineers rebuilt nearly everything to handle weight the original design never anticipated. The VH-92A runs two General Electric CT7-8A6 turbo shafts, and they're working harder than the commercial version would ever tolerate. Sikorsky's engineers faced a choice when they added 3,000 pounds to the airframe. Accept reduced performance or push the engines closer to their limits. For a helicopter carrying oil workers, reduced performance might be acceptable. For a helicopter carrying the president, it's not. They chose to push, and that decision would become one of the biggest problems with this helicopter later on. Each CT7 produces about 2,500 shaft horsepower per engine. That gives the VH-92A over 5,000 horsepower total. The civilian S-92 uses the same engines but manages them conservatively, keep temperatures low, keep stress manageable, extend the time between overhauls. Marine One runs them harder. If a threat appears and the pilot needs maximum climb rate immediately, those engines will deliver it. The maintenance schedule absorbs the cost. Engine components get replaced more frequently than civilian operators would ever accept, but replacement parts are cheaper than swearing in the vice president. Here's where things get interesting. The system managing all of this is called FADEC, Full Authority Digital Engine Control, and the VH-92A's version does something the pilot never could. Sensors throughout both engines monitor temperature, pressure, fuel flow, and shaft speed. They feed data to computers that make adjustments faster than human reflexes allow. When the pilot increases power, FADEC manages the transition to prevent temperature spikes that could damage turbine blades. When one engine starts running hotter than the other, FADEC rebalances the load automatically. The pilot tells the aircraft what to do. The computers figure out how to do it safely. This matters because the VH-92A's engines are already operating with less margin than the commercial version. The extra weight means more power demand at every phase of flight, takeoff, hover, cruise, landing. FADEC keeps the engines inside their limits even when those limits are closer than they should be. Without it, the pilot would have to babysit engine gauges. constantly, making micro adjustments to prevent over-temperature conditions. With it, the pilot focuses on flying while the computers handle thermal management. The redundancy runs deeper than just having two engines. If one fails completely, the VH-92A can continue flying on the other. Reduced capability, but controllable. If both engines fail simultaneously, the aircraft doesn't fall. The rotors keep spinning from aerodynamic forces as the helicopter descends, storing enough energy for a controlled emergency landing. The pilot uses collective pitch to cushion the touchdown. It's not gentle, but it's survivable. Marine One plans for failures that should never happen, because should never happen isn't good enough when you're carrying nuclear command authority, but 5,000 horsepower is useless if you can't turn it into lift. That's the transmission's job, and that's where the VH-92A's weight problem nearly broke the entire design. The main rotor on the VH-92A spans 56 feet and turns at 225 revolutions per minute. 4 composite blades cut through the air, generating the lift that holds 27,000 pounds in a hover. On a commercial S-92, this system works with comfortable margins. On Marine One, those margins have been spent on armor and electronics. The rotor system has to compensate. Each blade is built around a titanium spar, a structural spine running from root to tip that handles the centrifugal forces trying to tear the blade apart. Fiberglass skin wraps the exterior in an airfoil shape. Honeycomb aluminum fills the space between. The result is a blade that weighs less than solid construction, but maintains the stiffness needed for precise control. The VH-92A's blades aren't different from the S-92's in construction, but they're working harder. More weight below means more lift required above, and more lift means higher aerodynamic loads on every component. The rotor head is where the complexity multiplies. Each blade connects to the hub through a system of hinges and bearings that allow it to change pitch angle independently, tilting up or down, twisting nose high or nose low, adjusting 225 times per minute in patterns that would look chaotic if you could see them in slow motion. When the pilot pushes the cyclic stick forward, the rotor head translates that input into blade pitch changes that tilt the entire rotor disc, pulling the helicopter in the direction of the tilt. The VH-92A's flight control computers assist this process, smoothing inputs and preventing the kind of abrupt commands that could overstress the system. The transmission sits between the engines and the rotor head, and it's solving a physics problem that would otherwise make helicopters impossible. The CT-7 engines spin their output shafts at roughly 20,000 RPM. The main rotor needs to turn at 225 RPM. The transmission handles that reduction nearly 100 to 1 through a series of planetary gear sets machined to tolerances measured in 10,000ths of an inch. The forces involved are enormous. The heat generated requires constant oil circulation. The VH-92A's transmission is one of the hardest working components on the aircraft, and it's handling more load than the commercial version because of the weight it's lifting. The remarkable part is that despite this engine working overtime, the president feels nothing. The VH-92A uses active vibration control systems that the S-92 doesn't carry. Sensors detect oscillations from the rotor system. Actuators in the airframe generate counter vibrations that cancel them out. The cabin stays smooth and quiet while the mechanical systems above it work at their limits. This isn't just about comfort. Stable conditions matter when you're reading classified briefings, and they matter even more when secure communications equipment needs to function without interference. Vibration can degrade signal quality. Marine One can't afford degraded signals. The helicopter is now crossing the National Mall at 150 knots, the Washington Monument, sliding past the windows halfway to Andrews. The president hasn't felt a single vibration, but the systems keeping him connected to the outside world almost ended this program before it started. The VH-92A achieved initial operational capability in December 2021. The president didn't fly on one until August of 2024. That gap, 2.5 years between technically ready and actually carrying the commander-in-chief, it exists almost entirely because of the communication suite. Marine One has one job that no other helicopter in the world shares: maintaining nuclear command authority in flight. The president must be able to authenticate his identity, receive threat briefings, and issue launch orders from the cabin of this aircraft. The communications links connecting him to the Pentagon, to Strategic Command, and to the National Military Command Center have to work flawlessly. flawlessly. Encryption has to be unbreakable. Transmission has to be instantaneous. Redundancy has to cover every possible failure mode. The VH-92A's communication systems were designed to meet these requirements, and they failed testing repeatedly. The specifics are classified, but the broad strokes became public. Encrypted channels didn't perform reliably. Systems that worked fine on the ground malfunctioned in flight. Integration between components produced unexpected failures. The Marine Corps kept testing, kept finding problems, kept sending the aircraft back for fixes. Meanwhile, the president flew on VH-3D Sea Kings that had been in service since 1974. Ancient airframes with communications technology that had been upgraded so many times the wiring diagrams looked like abstract art. What finally made the VH-92A work remains undisclosed, but the capability it provides is clear. Secure voice channels connect to military and civilian leadership worldwide. Encrypted data links transmit documents and intelligence in real time. Satellite uplinks provide coverage over oceans and polar regions where ground-based systems can't reach. The aircraft carries multiple antenna arrays with overlapping coverage because losing signal isn't an option. If one system fails, others take over. The president stays connected no matter what. The cockpit reflects this communications first design philosophy. 4 glass displays dominate the instrument panel, replacing the analog gauges of older helicopters with screens that can show anything the mission requires. 3 independent flight computers cross-check each other constantly. If one produces anomalous data, the other 2 override it. Navigation runs through GPS primarily, but inertial backup systems track the aircraft's position using gyroscopes and accelerometers that need no external signals. If someone jams the GPS, Marine One keeps flying on dead reckoning, alone, calculating from its last known position using time, speed, and distance. The VH-3D Sea Kings that the VH-92A replaced were technological antiques by the end. Their basic airframes dated from the 1960s. Their communication systems had been upgraded piecemeal across 5 decades, layer upon layer of modifications that introduced complexity and failure points. The VH-92A was supposed to solve this with clean sheet integration. Modern systems designed to work together from the start. The execution took longer than anyone planned, but the result is an aircraft that does what Marine One actually needs to do in 2025. The helicopter is crossing the Potomac now, Air Force One visible in the distance. Communications are perfect, the flight is routine, but routine is a luxury that Marine One can never assume. And the systems protecting this aircraft from threats are working just as hard as the ones connecting it to the White House. The president is the highest value target on Earth. And for the next 2 minutes, he's traveling in a slow-moving aircraft following a predictable flight path toward a fixed destination. Marine One has to assume someone is watching with hostile intent. The defensive systems exist because that assumption might be correct. The VH-92A carries missile warning sensors that the commercial S-92 has no reason to include. Infrared detectors scan constantly for the heat signatures of incoming missiles, the kind of shoulder-fired weapons that have brought down military helicopters in every conflict zone of the last 40 years. These missiles home in on heat, and helicopters produce plenty of it. Engine exhaust, transmission friction, even the rotor blades warming from air resistance. A basic infrared seeker can lock onto any of these signatures. The VH-92A's sensors detect that lock and alert the crew before the missile ever launches. The countermeasures respond automatically. Flares eject from dispensers built into the fuselage. Decoys burning hotter than anything on the aircraft, pulling missiles away from the real target. The VH-92A also carries directed infrared countermeasures, laser systems that can blind a missile's seeker head and send it tumbling off course. The technology is similar to what protects Air Force One. Identify the threat, calculate its trajectory, scramble its guidance before it gets close enough to matter. Electronic warfare systems handle a different category of threat. Radar-guided missiles require tracking data, and tracking data requires radar signals. The VH-92A can jam those signals, filling the electromagnetic spectrum with noise that makes targeting impossible. The specifics are classified heavily enough that even acknowledging the capability borders on saying too much. What matters is the philosophy. Marine One tries to prevent attacks from developing, not just survive them once they begin. The final layer is deception, and it's the most visible one. Marine One never flies alone. When the president travels, multiple identical VH-92As take off together, following different routes to different landing zones. From the ground, they're indistinguishable. Same livery, same profile, same defensive systems active. Nobody watching knows which helicopter carries the president until he steps off. This shell game adds uncertainty that even the most sophisticated adversary can't eliminate. The VH-92A begins its descent toward Joint Base Andrews. Nothing has happened this flight. Nothing usually does. Marine One operates in some of the most secured airspace on Earth. Fighter escorts available on minutes' notice. Surface-to-air coverage blanketing the national capital region, but usually isn't a word that Marine One's mission planners trust. Joint Base Andrews appears through the windscreen, 90 seconds to touchdown. The defensive systems will stay active until the wheels stop rolling. The aircraft that almost didn't work is about to complete. Another perfect flight. How it got here is a story of engineering failures, political pressure, and problems that took years to solve. The wheels touch concrete at Andrews. The rotors begin their slow wind down 4 minutes from the south lawn. Barely enough time for a threat to develop. More than enough time for everything mechanical to go wrong. Marine One completed the mission again. The systems held. The president is walking toward Air Force One, probably without even thinking about what just carried him here. The VH-92A replaced helicopters that had been flying presidents for 50 years. The VH-3D Sea Kings first carried a commander-in-chief in 1974 during Nixon's final months in office, and they kept flying through every administration after: Ford, Carter, Reagan, both Bushes, Clinton, Obama, Trump, Biden. The same basic airframe, upgraded endlessly but never replaced. By the end, those helicopters were technological fossils. Their communication systems were patchworks of modifications layered across 5 decades. Their avionics mixed 1970s gauges with 1990s screens with 2010s computers. Parts availability had become a constant problem. The Marine Corps was nursing aircraft that should have been retired years earlier. The VH-92A was supposed to fix everything, and it almost fixed nothing. The program launched in 2014 with deliveries planned for 2020. Then the communication systems failed. Then the engines scorched the White House lawn. Exhaust temperatures literally burned the grass, which becomes a problem when your primary landing zone is a historic garden that groundskeepers have maintained since 1800. Pentagon testers called the aircraft unreliable and unsuitable for emergency operations. The Marines pushed back deadlines, demanded fixes, waited. Biden finally flew on a VH-92A in August of 2024, almost 4 years late. The communications problems had been solved through methods that remain classified. The exhausty issue had been addressed through thermal management redesigns. The aircraft that couldn't pass testing had finally met standards that no helicopter had ever met before. 23 VH-92As now serve the presidential fleet, 21 operational aircraft, and 2 dedicated test platforms. The old Sea Kings are retiring one by one. Their 50-year service lives finally complete. The transition will continue through 2030. Until then, the Marine Corps maintains both fleets, old and new, antique and modern, flying side by side in the world's most demanding helicopter mission.